Welcome to this video where we're going to explore what happens when we take samples from a population and then put those samples into a sampling distribution. So what you see here is an applet here in StatCrunch. You can get to it on your own if you want to try this yourself with the applets menu near the upper left. And then you would go down to sampling distributions here, and that'll pull up this box here. I have a right skewed population to start with, and I just changed the upper bound to 100 just because I could, and I click compute. And what that does is it gives us sort of a population of data that is very much right skewed, so obviously this is not a normally distributed population. And what we see here in the middle is that we're going to take a sample size of only 2. So when we take a sample from this population, it's only going to have 2 elements or people or observations in it. And then it's going to calculate the mean of that sample of size 2 and put it down here in the sample means graph at the very bottom. So if I do this one time by clicking this button near the upper left, you can see those 2 gray observations are chosen from the population. And then when you take the mean of those 2, it's 4.226. That gets plotted into the distribution of the sample means down here at the bottom of the screen. And so this represents one sample that has a mean of 4.22. That sample size is 2, and it comes from the population. So if I were to do this one more time, notice the animation actually shows 2 observations coming from the population. They're gray. They drop down to the middle sample graph, and then once the mean of that sample of 2 is computed, then that drops down here as a little green box. So if I do that one more time, watch carefully. There's the 2 samples, and there's the there's the 2 observations for that one sample, and then the mean of that new sample is down here. Notice it saved this first one. Okay, so this is one sample of size 2. Here's a second one. Here comes a third one. Now I can do this 5 times. Right? You can see it's going to do it 5 times. And that animation is going to take quite a while. But you can see actually the distribution is starting to be built. And if I do that 1,000 times, maybe 1,000 more. All right, keep doing that. I'll click that several times. I've actually got 8,000 samples, a lot of them. And you can see that that sampling distribution is no longer looking like the population, but it's still skewed over here to the right. So let's take the sample size and, well, actually, let's go back to the edit screen and then just compute again to kind of clear everything. Let's make the sample size 5 and then do the same thing, but I'm just going to skip to the fun part and do it 1,000 times first and continue to do it 1,000 times till I get to about 8,000 samples like the previous one. You can see that it is still right skewed, but not quite as badly as it was before, down in the distribution of the sample means. So increasing the sample size from 2 to 5 definitely altered the distribution of the sample means, but probably not too significantly. So what I'm going to do now is I'm just going to change the sample size from 5 to 10 and do the same thing. And I just want you to observe what you see. So here's 8,000 samples of size 10. And now let's go ahead and do that for a size of 15. 8,000 samples. Look at the distribution of the sample means. And now let's go to 25. So what are you noticing? And if you're not sure what's going on, you might want to actually do this yourself in StatCrunch. But let's go to a sample size of 30, which is our goal here. And let's take 8,000 samples. If you look at the mean of all of those samples in the sampling distribution, it's 28.026. Compare that to the mean of the population. What are you noticing? If you look at the standard deviation of the population, which is about 23.65, and compare that to the standard deviation of the sampling distribution, what are you noticing there? And you can play with this. We could go back to a sample size of just 15. Let's cut it in half and do that again and go about 8,000 samples. And you can, again, look at the mean of the sampling distribution, compare that to the mean of the population, and then compare the standard deviation of the population to the standard deviation of the sampling distribution. What's going on? That's what this question is asking you to look at when you do the reading here. So I'd encourage you to play with this. Once again, to do this on your own, let's close everything off so you can see how I got this. I go to applets, I go to sampling distributions, go to right skewed. You can leave the upper bound at 50 if you want to. It's not going to matter. And then begin that process. Change the sample size and see what happens. You can also go back and start with a completely different kind of distribution. Like a uniform distribution would look like this. Everything is uniformly distributed across all values in the population. And you can do the same exact experiment. You can start with a sample size of 5, take many different samples of size 5, and start to see what the sampling distribution looks like. So it turns out that the shape of the original population distribution isn't really going to matter as the sample size increases. So these are all ideas you'll want to play with a little bit, and then you can answer the questions below.